This video is an introduction into functions. A function is a collection of statements that are executed together and usually has input which influence the objects that are returned. Watch the OpenCourseWare video on scope of variables. I expect that you already know local and global variables from that video, so I'm not going to cover most of those topics. In this video, I intend to accomplish the following things: how to define a function in Python, a very simple one. We'll do multiple inputs. We'll see how easy those are, multiple outputs, and how to get the information or unpack the information from those. Lambda functions, so there's a one-liner that we can use in order to define functions, and it's done all the time, so you got to kind of know what those are. And keyword input, as well as positional arguments. So you got keyword arguments and positional arguments, and so we'll cover those as well. I'm going to do all of that in Python, in Anaconda. So let's go ahead and start that. So if I'm going to define this function, an example of how you define a function in Python is a little different than maybe R or C or whatever you've seen in the past, but it's DEF, meaning define. So I'm going to define a very simple ×3. So I'm going to put in an input. So in this case, the X is the input. The ×3 is the name of the function. And Python thinks of everything as an object, so it's going to create this object called ×3. And all we're going to do is return 3 times X. So that's going to be our very simple function. And hopefully we'll see what it looks like. So we can times 3, maybe 4. So we see a different number. And we see that it comes out as 12. So there's a couple of different things you can do with this. Because it's a return statement, and this 12 actually gets pushed out of that thing. So we can assign it to things. We can say x1 is equal to F9, and then we can print x1. And you can print 12. So 12. So if I looked at the variable explorer, you'll see. Matter of fact, let me restart the kernel. We'll start it all over. And I'll redo all these. So F9, you can see that x1 is equal to 12. And if you put another number in here, you don't have to rerun. So I guess one of the things that students have an issue with is if you don't change anything inside your function, you don't need to rerun it. If I just want to change the input now, I can put 6 in there, and it'll change what x1 is. So the next thing we want to talk about is defining maybe multiple inputs. So suppose that I don't just care about multiplying 3, but maybe we multiply something, 2 numbers, right? Maybe x and y. Let's return x times y. And again, it's returning this information, so we can assign it to something. Maybe xy is equal to multiply 5. So let's highlight these, run them, and we can print. So one thing I don't think I showed you guys, if you put a semicolon here, you can put another statement after it, and it'll treat it as 2 lines. So if I want to print xy, multiply and then print, you get 30. So that's what we expect it to be. Another one, maybe you want to have multiple output of a function. So let's define arithmetic. I'm going to put in 2 numbers. So multiple input, and these are positional numbers right now. At least that's the way we're putting them in here. And I'm going to return x plus y, x minus y, x times y, and x divided by y. Let's find out what happens when I put in 3 and 8. All right, so let's run this and see what happened here, right? So remember what the parentheses represents. So I think we learned last class that that a parenthesis represents a tuple. So this is a tuple, 11, -5, 24, and 0.37. And if you just assign it to some A, if I just assign it to A, it would come out as a tuple. If I wanted to find or assign it to a couple of different things, maybe we want to assign it to, we can unpack this thing is what I'm trying to say. So I can unpack this all in one line. And let's say maybe this is add, subtract, multiply, and divide. And we hit F9. And now we have 4 different numbers that are equal to what this one tuple was equal to, right? So add is equal to 11, subtract is equal to -5, 24. So it's unpacked this result that came out, right? Because it was a length of 4 tuple, a tuple with a length of 4, and then it just put it into each one of the things. Now, if you don't put in enough of these, it'll give you an unpack error, right? So too many values to unpack, expected 3. So in other words, arithmetic gave out too many. So that's what that thing's telling you, because this stuff on the left-hand side is what you're trying to assign it to. And why did it expect 3? Because I only had 3 on the left-hand side, but this thing gave me 4. So that's sort of how you read that error. So we can come back and put in the div back in and hit F9, and then we can print that out if we wanted to. The next thing we want to cover real quick is a very quick way of, so if you have a very easy function and you don't want to put, so for example, so say we're going to do the squared function. So def of x, return x squared. That's one way of doing it, and then I can do f of 2. We know it's going to be 4, and so you can see the 4 coming out, right? So that's one way of doing it, but Python has given us a very quick way of doing it. So just by saying f is equal to lambda, and then you got to put the variable, and then a colon, and then you describe the function. So it's a little quicker. It looks a little nicer. It kind of looks mathematical. So that's the idea behind it. So F9, and then F of 3. F of 3 would be that. So maybe we do it G, F9, and then you can see that it actually is. So maybe you were confused because I had F up here and then F down here. But we just defined this function G, and it gives us the same thing. Another thing that you can do is you can actually give it more than one parameter, right? Just like you can in a regular def function, you can give a lambda function more than one. So maybe G is lambda x comma y, and then x squared plus y. F9, and now if you try to do G of 3, it's going to give you an error because it needs 2. So I need 3 and maybe 2. F9, so 9 plus 4 is 13, so that makes sense. And still another way to do it is to pass it in as a vector. Now, if you do it this way, and this is a way that is beneficial because then you're not stuck at just 2 or stuck at just 1. If we pass it in as a vector, I can have anything over here on the right-hand side. For example, let's have h is equal to lambda x. So my assumption here now is that x is going to be some list. So it's something that has a container of values. And I'm going to assume right now that it has 2. It has x0 plus x1 squared. So we can pass in the same thing that we did before, but instead I got to put it in a container. So a list, if you will. So if I pass this in, then it thinks x0 is the first, whatever the first number is in here, and x1 is whatever the second number is. So let's highlight this, and we should get the same thing that we got before. And you can see G of 3, 2 is equal to H of 3, comma 2, right? So the 3, 2 is equal to H of the vector, right? So if you don't think of this as a vector, at least for right now. Okay, so and we can return more things than just a single number. We can do more stuff than that, but that's all I wanted to describe today. And then finally, keyword argument. So now I want to introduce docstrings and this idea of keyword argument, all sort of in the same example. So here's what we want to do. Produce a list of multiples of x. For example, if I pass in x as 3, so the number that you are multiplying. So 3 is going to be the number we're going to multiply. Then I want it to go 3 times 0, 3 times 1, 3 times 2, 3 times 3, 3 times 4. Oh, here you go. So multiple of 3. So this actually should be 5. It's because this is 5 times 0, 5 times 1, 5 times 2, and so on and so forth. So that's what we want to do. I want to produce something that does that. And what we're going to do, if you read the doc string here, is it's equal to 9. So in other words, I'm going to go from 0 to 9 right away. That's going to be my default, unless I have a different keyword for num. So let's see what that looks like. I know what I think I know where, oh, there it is. So there it is. So I know that I want the name of the function to be multiply row. So multiply row. And then, of course, we're not going to put in 5 because we don't hard code anything. But we put in x because we said that's going to be my input. And then num is equal to 9. So that's your default. That's what we're going. If you don't put anything in there, you don't have to put anything in there. If you put nothing, then it's going to think it's 9. And then what am I going to do now? Well, I'm going to produce a list, right? So I'm returning a list of multiples of x. So I'm going to start off by initializing this x, and I call a lot of stuff res, result, or ans, answer. In this case, I'm just using result. So result's equal to this empty list, and that's going to start us out. And then I'm just going to simply go from I in range, let's see, num, and if I wanted to stop at 9, then I got to add 1 to it. So I'm going to do that, and then we're simply just going to append all of the numbers to it. So append I times x, then return result. So that's this is a very easy function to at least think about, because I think everyone's sort of seen a multiplication table before. We're at the end, the very last video in this series here. We're gonna think about how to decompose a problem of doing a multiplication table. But in this case, we've just decomposed it into, if I give you a number, then give me the list of numbers that it multiplies by out to that particular multiple. So let's highlight this thing, F9, and then let's run one. Let's run this one to make sure that it gives us the same thing that it should. And it should have given us that, and it did. Okay, well, that's all I got. I hope you guys got something out of it, and I will see you next time.